Okay, so this is for G, so you've decided that this is R1, R2, R3, R4, and the first thing that you do is you reorder the circuit to get RL to be on the far right. So you've essentially picked up that branch with the 4 and the 10 and moved it over with the branch with the RL. So you're going from that to that. You've just moved over these two branches. Now when you do the Norton current, you put a short circuit where your RL would be. So that's your first step to do your Norton current. So you've got the same circuit. So you've still got that 18-volt supply. You still get the 12 ohms across it. You've got the other 12 ohms. The 4 and the 10, you could really just decide that's a 14 ohm, to be fair. You don't have to do it as a separate 4 and a 10. And then that is where your Norton current flows. Because your Norton current completely shorts out this branch here that's got R3 and R4 in it, you can disregard that branch. So you just disregard that whole thing. So now your Norton current doesn't become this circuit. So this is R1 and R2, these two 12 ohms. Your Norton equivalent circuit will go from being that to being that. That's your Norton current there. And that would be the current you're trying to find there to get your Norton current. To get the current IN, you know the voltage across it's the same as the supply voltage. It's just a parallel circuit now. So it's 18 divided by 12. 1.5 amps. It's as straightforward as that. So it's just I equals V over R. You know the voltage across that resistor there has to be the same as the supply voltage because that current path just goes from that junction to that junction, right across the supply, and then the resistance in that path. So you've got the voltage across it, so why not make it easy for yourself? And that's your Norton current. So the other thing that you have to do is your Thevenin or Norton resistance. So have a wee look at how you're going to go about that. So this time, remember what you do is you short out the supply. So it's as if that's gone. And you're keeping the rest. For the sake of making things a wee bit more simple, I think I'm just going to combine that 4 and that 10 and just make it a 14 ohm. And then remember you're kind of pretending the supply is over on this side. And you're working out the resistance looking in from here. The first thing that you should notice is again you've got a short circuit across a resistor. So this one is going to be disregarded. Then you'd move on from that. So that's your kind of simplified equivalent circuit. Bees. So to get the Norton resistance, you should have just done that 12 ohms in parallel with the 14 ohms. So whichever way you want to do it, whether you want to do it the product over the sum or you want to do the 1 over method. So we'll use the 1 over method, 12 1 over plus 14 1 over equals final 1 over. And for my R Norton, I've got 6.462, 4 significant figures. So now at this point, I've got a Norton resistance there that I'm going to use. And I've got my Norton current there. So now I can do my Norton equivalent circuit. So your Norton equivalent circuit, if you remember, is a current source with a parallel resistance and then you put your load resistance back on again. So that's your I Norton, your 1.5 amps. Your R Norton, 6.462. And then your RL, which took off away at the start up there, 12 ohms. So if you wanted to get your load current, your IL, it'd be your Norton current that you'd divide. And bracket that because there's two numbers on the denominator. So that's getting me 0.525. 5250 when you round it to 4 significant figures. That's my current through my load. And then if you want the voltage across the load, it'll be IL times RL. So it'll just be that value there, this value there, multiplied by this 12. And that gets you 6.3 volts. And that would be it, finished.